In section 8, we are going to talk about relative velocity. You are all intuitively are familiar with the concept of relative velocity. For example, if you are in a car, and let's say you are moving with a velocity of 1 meter per second to the right, and you have another car, there is another car which is moving with the same velocity, 1 meter per second to the right, you know your relative velocity with respect to the other guy is 0 because both of you are moving with the same velocity. If your velocity, let's say, is 2 meter per second and that one is 1 meter, your relative velocity is going to be 1 meter per second toward that guy, toward the other car, because you're getting 1 meter closer to that one every second. Or if the velocity of the other car is 1 meter per second toward you, your relative velocity is going to be 3 meter per second to the right with respect to this one. So these are all intuitive without knowing the math behind it. But for more complicated problems, it's not going to be quite easy. For example, let's say the car is going that way with a velocity of 1 meter per second. Then what's going to be your relative velocity with respect to this one? So to understand all of these and solve more complicated problems, and also even talk about the accelerations, I'm going to give you a mathematical frame behind this relative velocity, and finally we are going to develop some equations for it. So let's use an inertial frame. Let's say this xy coordinate is sitting on the ground, and we have two particles which are moving around, particle A and particle B. If I want to show the location of these particles in this coordinate, I can use two vectors like RA and RB to show the location of these two particles. The relative distance or the relative location between A and B is going to be this vector. A with respect to B, with respect means you are putting your origin over there, is going to be this vector. This is the location of A with respect to B, which we show it with this symbol. So if I want to write it mathematically, R of A with respect to B, which is this vector, it's equal to RA minus RB, which is trivial. Now, if I take a derivative from this equation with respect to time, derivative of R is velocity. So velocity of A with respect to B is going to be equal to derivative of R with respect to time, which is velocity of A minus velocity of B. As simple as that. So if you have two particles which are moving around, to find the relative velocity of A with respect to B, you need to subtract velocity of B from A. And the physical meaning of velocity of A with respect to B, it means the observer is going to be on B. Let's say we are moving with B and we don't know we are moving. And in the same time, we are looking to point A. The velocity of A in our eyes, based on our observation, is going to be that relative velocity. The relative velocity of A with respect to B, with respect to us. So this is the equation for velocity. And also in the same time, you can write velocity of B with respect to A. If you want to do that, you can use the similar equation. So, but everything, you need to switch A and B. Velocity of B with respect to A is going to be equal to velocity of B minus velocity of A, which is equal to opposite of velocity of A with respect to B. And you can take a derivative of the velocity equation another time to find acceleration equation. Derivative of velocity is acceleration. So acceleration of A with respect to B is equal to acceleration of A minus acceleration of b. So the theory behind the relative velocity is quite simple, and we have only these two equations. But we can use these two equations to solve relatively complicated problems.